Hello, everyone. Great to have everyone here. It's like Koyeb and Pruna announcements for our collaboration that we've been working on really hard. It's nice to have John here from the side of Pruna, one of the founders of Pruna, and then also Yann. Thank you for being here. Initially, we'll go over some of the release highlights that we've been working on over at Pruna, maybe give a brief introduction to our new documentation, and then after that, Yann will showcase a demo of this one-click deployment thing that we've been working on. And then after, John will actually go into some of the underlying mechanisms and techniques that's under the hood for Pruna, actually to optimize the model that's being served there. Some cool things that we've been working on during the last release and some releases that we'll be doing in the future is actually moving over some of the algorithms that we initially had as pro integration to like the open source solution. And one of the things that we also included is like this new overview of our documentation. As you can actually see here, we have some overview of serving integrations like Koyeb. We actually updated a lot of these user manuals to be more user-focused and user-oriented and task-specific, going from like smashing your model with some nice visualizations to actually evaluating and running evaluations on top of your optimized models, so that everything should be a bit more clear to the end user and to you, similar to like an overview of tutorials and these kind of things. But the cool thing, what we've been working on recently is like this Koyeb integration. We have a nice end-to-end tutorial for this, but actually Yann is going to showcase how you can directly deploy like Pruna optimized models with the Koyeb serverless inference platform. And so I will be giving the stage to him.
Awesome. Thank you, David. So yeah, I can give you all some context on what we're doing here at Koyeb and what we actually have been working on with the Pruna team, and I can actually show you how it works on the platform live. So that's going to be fun. Basically, to give some context, we're a cloud service provider, and we let you deploy apps and models in general. And so what we provide is an infrastructure where you can deploy across multiple locations worldwide, including 4 locations in the US, 4 in Europe, and 2 in Asia. And you can access CPU, accelerators, and GPUs. And so today we'll be focusing on the serverless GPUs and how to actually get like Pruna live and how you can actually test the performance improvement with Pruna. We have a demo with like FLUX.1 dev optimized using Pruna, and yeah, but technically anything which works with Pruna is going to work with the platform in the same way. So I know we picked like FLUX.1 dev. I don't know if there is anything else on your end, guys, which people should be aware of in terms of models that they should try out, or if FLUX.1 dev is like still like the one which is the most interesting.
Yeah, we've got
Yeah, sorry, I was just going to say Flux is still like kind of the most popular, has the biggest community right now. But basically any model that you want to deploy on Koyeb, you can basically use Pruna on any image generation, video generation, LLMs, anything like this. So we're really like model independent in that way.
Excellent. So I guess like we can actually look at it together and see how easy it is to actually get Pruna live. So in the page which I'm scrolling on, basically I think it's accessible directly in the Pruna documentation. So this is on our website. If you go to koyeb.com, you go to the deploy section and you actually look for Pruna, you'll find this example. It's pretty simple. So there is a getting started, an example on how to use it. And that's actually what we are going to do together. If I hit basically the deploy button, it's going to let me deploy on a serverless GPU immediately. And this is the Python code, which we will be using to actually simply query the running, which is optimized with Pruna. And below we see the prompt and how like we can actually the different parameters we can give. And I have 2 demos for you today. One is like actually this with simply to query and basically the Python code, and we'll get a result similar to this one at the end. So if I hit deploy, actually it's going to bring us like to our control panel, and we'll be able to pick the Pruna AI model and pick the model on which the GPU count, on which I want to run. So I can pick across like any GPU which has enough RAM for this model. So typically this one, at least we defined it as requiring at least 48 gigabyte of VRAM. So you can use an RTX, an L40S, an A100, depending on the performance you need. And basically this deployment is going to auto scale. So we can pick the region. We're going to pick North America because there is more stock. And it's going to auto scale by default between 0 and 1 instance. So if there is no traffic, the machine is going to sleep. And when there is active traffic, the machine will be awake. And basically what I have to do is pretty simple. And actually, since I already deployed something with the same name earlier, it's actually here and it's pre-set up. So we don't have to deploy it again. And basically what we see as being deployed is here. It's a Docker container where we can share the sources with you all, actually, and it's using Pruna behind the scene. This deployment is actually using an L40S, as it's similar to what I was aiming to deploy, and it's like scaling between 1 and 4 instances in North America, because I updated like the setup earlier so that it doesn't sleep. If I go on this URL, actually I have something which is ready to use. So it's not going to be highly visual because it's just like an API return. But basically, I have 2 demos which are leveraging this deployment. One is front-end and the other one is a Python script. So we'll start with the Python scripts. You're going to see shortly my terminal, and we are going to check what is the Python script actually. So the Python script is pretty simple. It's the one which is on the deploy page. Maybe we can do with Vim. It's going to have more colors. And basically, we see that it's querying like the URL that we have here on the left. And what it's simply doing, it's making a call and saving the image, basically. So it's like pretty simple. It's the example we have. At the end, it's sharing like let's see, this is also like showing up. So it's saving in a file called output image GPG. So yeah. And so basically, we have already one of my tests earlier, so I can remove this file and I can run it, and we'll get shortly like an image. And we have an image which is similar to the demo. Do you guys need to see? Do you want guys to generate anything else? We can change it if we're wild.
I have a favorite prompt.
What is it?
That always breaks these models. Cat jumping in the air to catch a bird.
Catch a cat jumping in the air to catch a bird. Okay. And now, okay. Did it like, yeah, okay. Sounds good. Let's see what happens now. All right.
Oh, it's pretty good.
Yeah. So yeah, and this is running basically on Koyeb with Pruna. So we actually we should see the requests actually coming up somewhere in the logs. And we have the same thing visually, like using Pruna here. So it's exactly the same. It's just a front end we generated, which is doing the same thing. And we can adjust like the different Pruna settings directly. So the prompt we had was like, we could do something different, but let's say we'll do a dog ad, and we can adjust the different like feed settings, extra reduced, predict.
Now it broke.
Yeah.
Cool. Before we continue with the presentation of John, I think there were some questions. One of which, like this demo UI thing, that is that automatically generated from the side of Koyeb, something that you can deploy?
We basically, I think what we did on this one is we have a separate front end that we did quickly. So it's here, it's some like, I think we need to ask Ed, because he did the front end quickly before, but I wonder if he didn't do it with Lovable, because we were testing if we could do it like quickly. But it's here, it's like, in this case, it's a simple deployment with a Docker file of basic front ends that we did. So the two are different components on our platform, which we deployed. And technically, like the front end is separate and it doesn't scale like the back end in the architecture we deployed right now.
Okay, great. And do you also keep track of some like metrics? I can see like a tab there that kind of gives an overview of requests coming in, CPU, GPU usage. And
yeah, you see like CPU memory usage and response time. So I think that depending on the prediction we made, it's probably like, that's probably why we have the variation depending on the parameter we gave. Like we see there was only one request, but basically what we can do here is we can do a simple like script on the fly which is like, and it's actually going to auto scale depending on like, I need to remember my, I need to practice my bash shell scripting. What is it, like it's sec with something like this? You guys remember? I'm like rusted.
My bash is also a bit rusty, especially
I
with
think now you don't need any of this anymore.
Yeah.
I use like inside of cursor, I just tell it, okay, just do this in my bash.
Yeah, I forgot everything, like, okay, now. And so basically what we can do is we can generate some like artificial loads. Okay, it's going to generate a bunch of things. Like if I cut, it's because my Mac died. Let's say stop. Okay, I generated 300 comments, and we will see actually like the traffic stacking up. And basically, if it doesn't process a request fast enough, it's going to spawn up like additional instances. So,
and there was also an answer about that. So how long would you say it takes to scale up? Now we're using a L40, but the question was about H100. But
yeah, here right now, it's actually, we are seeing that it's allocating two new instances. So we'll see it live. And to the question that we have, it takes, so spawning a new virtual machine, because what we do behind the scene is we create a dedicated virtual machine every time. And so basically creating a new virtual machine takes between 5 to 10 seconds. The challenge is more like getting the thing to be loaded in VRAM. That's the real pain.
Yeah, it takes a bit longer. And then, yeah, models are big as well, but probably they're cached somewhere in some shared volume. Or
yeah.
I have a quick question. It's a bit continuing what David said. Is it possible to have some volume that is where you can kind of like store some things? For example, like when you compile models, usually you have like a big warm up in the beginning, and this like some of our customers that use serverless instances, they say, oh, like when we spin the machine up, then we have to do this warm up. But right now in Pruna, we made it possible that you can save this warm up kind of. Is it possible that like you have like some storage that the machine kind of like spins up with that has some things cached? Sorry, I'm not sure if it's a clear question.
Yeah, it is a clear question actually. And so the way we do it usually we bake stuff in the container most of the time when possible, because then there is like built-in caching. And I don't know why I have like this thing which is showing up on the right. Anyway, it's because I'm an admin, but wait. It's a bit, yeah. But anyway, so you can use volumes for persistent data, which are going to stay on the machine.
Okay.
And the other optimization techniques. So the main changes is like typically like VLLM implemented optimization to load everything directly. I mean, to accelerate the loading time basically in VRAM, and to avoid any compilation to occur at startup time. Basically, that's the main thing which we see occurring. But yeah, in general, like we recommend baking everything in the image for production cases, because then we have caching on every limit like startup time.
okay. Perfect. Thanks. I'm not sure if there were any more questions, but feel free to post them also during the presentation of John. And thank you for the presentation, Yann. There was one comment about potentially sharing some of the scripts and these kind of things. Then I can add them to a Google Drive or whatever and actually attach them to the video, so it's easier for people to reproduce. And then maybe John can go ahead with like actually showing what's going on under the hood from the Pruna side of things. Actually going over like this brief notebook that you prepared.
Yes. Okay. I'm anticipating some demo effect, but I guess that's fine. Can you see my notebook right now?
Yeah. Can you zoom in a bit more?
Yes. Is this good or even more?
A bit more couldn't. Okay, perfect.
Okay, nice. Yes, so I just wanted to quickly show what's happening on the Pruna side on this Flux model, and basically to show like any model that you could have on Koyeb. It's very simple to kind of integrate Pruna, and it won't really affect the way that your model is loaded and deployed in the end. So if you look at this notebook, so there's three main parts. There's the first part, which is loading the model, preparing everything. Then there's the optimization part, so optimizing it with Pruna, and then there's running the model. So first of all, loading the model, or in your case, it can be like anything from like preparing a whole pipeline of models or anything like this. So this is like happening on your side, unrelated to Pruna. In this case, we just simply load the Flux dev model. And then just for comparison reasons, you can see also I have my go-to prompt also here. For comparison reasons, we will just run the model on 28 steps, which is the default. And you can see it takes around 10 seconds. We can run it again just for warm-up reasons. Some models or most models, the first inference is not really the realistic one. So it is around 10 seconds. You can see cat jumping to get the bird. And then we can optimize the model with Pruna. You can see it's super simple. All you have to do is define a configuration. So in this case, our configuration, let's say, has a compiler, which is Torch compile, and a cacher, which is auto. And then you can also configure, for example, hyperparameters for the certain algorithm that you choose. For example, for the cacher auto, we want to use the Taylor cache mode, which improves the overall performance and quality of the model. And then all you have to do after that is basically just call the smash function, give your model as an input, the model that we loaded here, which is this pipe, and also give the smash config as an input, the one we just defined. So I will run this, and this is usually very fast. Some algorithms might need a bit longer time, but usually it's very quick. So you can see it took 9.3 seconds in this case, and then that's it. So you get this. In this case, I named the returned model also pipe. So now the pipe is optimized, and you can use the optimized model the same way you did before. So you don't need to change how you call the model, so what inputs you give or anything like this. So everything stays the same. And the goal here is to not disrupt basically what you do after optimization. So you can really like just plug Pruna in before you deploy your model, and it should work the same. Now, for this, we will have to wait a bit for the first inference. This is because we use Torch compilation here as one of the methods. And this was why I was asking, because usually there is a warm-up time in compilation. We released a new tutorial to show how you can remove this warm-up by kind of pre-compiling and saving the model beforehand. Not sure if someone can post this in the chat so that everyone can see. Okay, perfect. Okay, so actually it already ran. So in this case, you see it took 18 seconds for the first run, and the generated image is, I would say, almost the same as the original one, but now we can run it again to see like the actual speed, and you can see it's 3.5 seconds. Just one more time, just to make sure this is it. Yes, so 3.5 seconds is the speed. You can see image quality is still insanely good, but if we compare to the original model, which took 10 seconds, this is almost 3x faster. And the only thing you had to do is like a few lines of code. And yeah, so this configuration, for example, works on any diffusion model. It can be Flux Dev, Flux Schnell, Stable Diffusion, XL, Stable Diffusion, High Dream, anything you might think of, or any other diffusion models, even like text to 3D models, and others like this. And also we have different configurations also for LLMs. So yeah, any model you might have deployed on Koyeb, you can benefit from making it faster or smaller, to use even smaller GPUs and have better cost. But yes, this was what I wanted to show very quickly. If anyone has any questions, please let me know.
Yeah, so for the current model, like the Flux Juice model is available out of the box, I guess, as Koyeb integration. And then besides that, you can create your own like configurations and smash your own models and Docker images. Is that correct, Yann?
Exactly. So yeah, if you have any model deployed on Koyeb, you could also just plug in Pruna and have a faster model as an output.
And now we have this Flux Juice available out of the box. And do we like see like some other models coming available out of the box? Something that you discussed already, or?
I don't think we discussed anything very concrete for a next model we will showcase. I guess on the image generation side, Hydream could be a nice option because it's currently now like sitting at the top of the leaderboard as the new state of the art for image generation. I'm not sure if Koyeb showcases any video models. That could be one thing to show for a start.
Yeah, we've been actually like working on, I know we have like a few tutorials like on how to make like video models run on the platform. So definitely something we're looking at. I'm not sure if they are published yet, but definitely down to add some examples around this. It seems like we didn't push them. I know it's in the backlog to add some video models. So
Cool. Yeah. Then I guess from our side, happy to help with optimizing them, and yeah, maybe we can explore that a bit further, like during the coming weeks. Let me check if there's like remaining questions or remarks. Let's see, some love for Pruna and Koyeb. But otherwise, I'm not sure if there's like comments or remarks from your side, John, or from your side, Jan. But otherwise, I would like to thank you both for coming and presenting. I will make sure that all of the content that you shared will be available along with the video, some of the URLs that have been shared, and like all of the other remaining things and questions that will come online during the coming week. So thank you, and hope to stay in touch.
Thank you.
Perfect. Thanks a lot.
Bye bye.
Bye.
Bye bye.